Let's look at OpenStax College Physics, Chapter 10, Problem 6. Suppose a piece of dust finds itself on a CD. If the spin rate of the CD is 500 RPM and the piece of dust is 4.3 centimeters from the center, what is the total distance traveled by the dust in 3 minutes? Ignore accelerations due to getting the CD rotating. So let's organize our thoughts. Let's see what kinds of things we know. So the first thing we're told is that the spin rate of the CD is 500 RPM. RPM stands for rotations or revolutions per minute, so that is an angular velocity. So we know that omega is 500 rotations per minute, and that is not an SI unit. So I'm going to want to convert that into radians per second, and I know that in 1 minute there are 60 seconds, so the minutes cancel out. And I also know that there are 2 pi radians in 1 rotation. So then the rotations cancel out. And when we multiply these numbers out, we end up with 52.4 radians per second. So now we know the angular velocity of the CD. Then we're told that the speck of dust is at a distance r is 0.043 meters from the center. So I converted the centimeters to meters. And that the speck of dust travels through a time of 3 minutes. So time is 3 times 60 seconds is 180 seconds. We're looking for the total length of the path. So we want the arc length that the speck of dust traveled. So let's draw a little diagram here. So here's our CD, and the speck of dust is there, and this is distance r that we were given. So as the CD is spinning, so it's rotating like this, the speck of dust is going to go around and around like that, and it will travel some distance, arc length s. And we're looking for that length s. So I have a cheat sheet here. I have my equations, and I know that I can ignore accelerations. So that is something that I'm going to cross out. Now, in the first and last of these equations, all this tells me is that the angular velocity is constant, so I can't use those. But I can use the second equation. So I will say then that delta theta is omega t. So I know the angular displacement of the CD, and that will be 52.4 radians per second times the time, which is 180 seconds. And when I multiply these, I get 9430 radians. So then I can find the arc length using S equals r theta, and r was 0.043 meters, and theta 9430 radians. When I multiply these through, I get 405 meters, meaning that the speck of dust traveled a distance of 405 meters.